Hi everyone, this video is on the mixed exercise 12 question 14. So we have the curve with the following equation and the normals to the curve at the points O and A meet at the point N. So we want to find the coordinates of point N. So remember that N is the point of the intersection of the two of the normals. And this means that in order to find the coordinates of point N, we first need to have the equations of the normals, and then we set them equal to each other. And by setting them equal to each other, the solution to the equation is going to be the x coordinate of the point of the intersection, which is basically the x coordinate of point N. So we first need to find the equation of each normal. And in order to find the equation of each normal, we first need to find the gradient. So let's find the gradient of the curve at each of the points O and A. So let's rearrange the equation. We divide both sides by 2 and we get 3 over 2x cubed minus 7 over 2x squared plus 2x. And now we differentiate this. So we get 9 over 2x squared minus 7x plus 2. Now, in order to find the gradient at each of the points, we just need to substitute the x coordinate of each point. So let's just start with the point 0, 0. So when x is equal to 0, then the gradient is equal to positive 2. But remember that we want to find the equation of the normal that passes through the point 0, 0. So the gradient of the normal is the negative reciprocal of the gradient of the tangent. So that means the gradient of normal at the point 0, 0 is the negative reciprocal of 2, which is minus 1 over 2. So now we have the gradient of the normal. We obviously know the points because that's the point 0, 0 and that's the origin. So now that we have the point, yeah, maybe it's better to just write the same notation as the question. Now that we have the point, then we can find the equation of the normal by using the general form of the equation of a straight line. Y minus y0 is equal to m times x minus x0. So we substitute the points which are 0, 0, and the gradient is minus 1 over 2 and x minus 0. So basically the equation is equal to y is equal to minus a half x. So this is the equation of the normal at the point 1, 0. So the equation of the normal at the point 0, 0, as we said. Okay, but remember that we have also another point, so we need to find the equation of the normal at the point 1, 0. But remember that both normals, because we are going to use this divide by dx equation for both normals. So in order to find the gradient of the second normal, we now need to substitute 1 into divide by dx. So when x is equal to 1, then divide by dx is equal to, so if we substitute 1 into here, is minus a half. So the gradient is minus a half, and we know that the point A has coordinates 1, 0. So now that we have the points and the coordinate, we basically use the equation of a straight line again, just to find the equation. So we get y minus 0 is equal to, again, we find a negative reciprocal. So the negative reciprocal minus a half is 2. So this time the gradient is 2 and then x minus 1. So it is y is equal to 2x minus 2. Right. So this is the equation of the, again, equation of normal at point A. So at A. This one was at O. Okay. So now that we have both equations, we just need to find the points of intersection, right? So we set the two equations equal to each other. So to find n, we set 2x minus 2 equal to minus a half x. So that's the equation of the other normal. And yeah, so we just need to solve this equation. So it's let's multiply every time by 2. So 4x minus 4 is equal to minus x. So we get 5x is equal to 4. X is equal to 4 over 5. And this is the x coordinate of n. So in order to find its y coordinate, we just substitute 4/5 into the equation of the curve. And so when x is equal to 4/5, then the y coordinate is equal to minus. Sorry, I meant when we have the x coordinate, to find the y coordinate, we just substitute into the equation of any of the normals, because this essentially this point is on both of the normals, so it doesn't matter. We can just substitute in any of the equations of the normal. So we can maybe substitute in this equation minus a half x, so minus a half times 4/5 basically, which gives us minus 2/5. Okay, so basically the coordinates of points n are 4/5 and minus 2/5. So that's the solution to part A. So now for part B, we want to calculate the area of triangle AON. So we just need to first sketch that. So point O is here, is just the origin. Point A is 1, 0. So let's say that's here. And finally point N is somewhere here. So this is the triangle. And so we can just use the basic area of triangle, which is half base times height. And this is the base, and the value of base is basically 1. So we know the base, which is 1, and then the height is from here to here, which is the y coordinate of point N. So the point N has y coordinate minus 2/5, but length is positive, so it's basically 2/5. So that's the height. And yeah, so the area is simply equal to a half times 1 times 2/5, which is 1/5. All right, that's it for this video, and thank you for watching.